This meeting is being recorded.
For chapter 20, problem 22, we're asked here to predict the major organic products. So sometimes there's one, sometimes there's going to be more than one, for each of these following reactions. So let's start with part A here. And we see that we have our ester here that will be reacted with lithium aluminum hydride. And this will reduce our ester in a first step to an aldehyde through a nucleophilic attack and then loss of this methoxide group here. So that would be with one equivalent of lithium aluminum hydride. With the second protonation upon workup with aqueous acid, we'll actually see two equivalents of this hydride being incorporated into our product, and then a reduction from the aldehyde to an alcohol. So this is our first product here, this alcohol, which we can see is very structurally similar to our starting ester. And then we also would produce methanol. So two alcohol products shown here after reduction of an ester with lithium aluminum hydride and an acid workup. In part B, now we're going to see excess of this Grignard reagent. So remember when we have this general layout here of our magnesium bromide here, we know that this is going to be a Grignard reagent. In this case, we're going to add two equivalents of ethyl groups here, our R groups, to the site of this carbonyl carbon in our ester starting material here. So once again, we are going to see that in our product here, that at this point here, at this carbonyl carbon, we have added two equivalents of our ester to generate this alcohol here. And then again, we know that we have the Grignard reagent followed by acid workup. We'll also generate methanol here. Again, from that methoxy group that has left. So we have two organic products shown here. With part C, let's take a look and see what happens here. We're going to now use again excess lithium aluminum hydride, our reducing agents. So what we're going to do is we're actually going to break this ring structure, and if we break it here, we can see how we end up with 1, 2, 3, 4 carbons. Actually, let me start that count again. We're going to have this carbon up top here be carbon 1, 2, 3, 4, 5, and then we see that here 1, 2, 3, 4, 5 carbons in our product. So let's explain what happened here. The first equivalent of lithium aluminum hydride reduced our ester to an aldehyde, similarly to what we saw in part A. So we had nucleophilic attack and then loss of leaving group. So then we have, with the second equivalent being added, we would reduce our aldehyde to the corresponding alkoxide that we see here. And then once we add our aqueous acid, we would protonate that alkoxide. So this is the only product that we would see for the cyclic ester being treated with lithium aluminum hydride and an acid workup. Then in part D here, we have, once again, starting ester. We're going to just treat this with aqueous acid. And we're going to see that this is hydrolyzed. So we're going to break this apart here at this point. And we will produce, we'll produce ethanol, shown below here. Over here, ethanol from this ethoxy portion, and then we'll also create this carboxylic acid shown here. Let's see. So in acid, this was acid catalyzed conditions, right? And let's see, in part E, so in step 1 here, benzoic acid would be deprotonated by our sodium hydroxide. We'll produce a sodium benzoate salt intermediate, And then we'll see a subsequent SN2 mechanism here, where we add this ethyl portion to our final product. So this would be benzoic acid treated with sodium hydroxide base, and then deprotonation happens, and then a SN2 substitution to produce our ester product this time. In our last example here, we have another Grignard reagent which attacks our carbonyl group. So the cyclic ester would be converted to an acyclic ketone. At that point, we'll have another nucleophilic attack of the ethyl magnesium bromide, followed by loss of leaving group. And then eventually we'll see this second equivalent, since we have excess Grignard reagent, being added to our carbonyl carbon. So at this site here, we're going to add those two ethyl substituents. And then we're also going to be breaking this ring here. So we see the remaining what do we have here? 1, 2 carbons, right? 1, 2 here in our chain. And then this oxygen here will become protonated in the acid workup step. So overall, we added 2 ethyl substituents, which are incorporated into our product. And then we end up breaking that ring and protonating this oxygen here to form this other hydroxyl group.